In these next two operations with complex numbers, you'll see that fractions are involved. In example 7, we're going to be multiplying fractions that involve complex numbers, and then in example 8, we'll add fractions that involve complex numbers. So when we are multiplying with fractions, we don't need to be concerned with common denominators. It doesn't matter what the denominators are. We will be able to multiply the numerators of each term, multiply denominators of each term, regardless of whether they match or not. As you can see here, we've got two binomials. So we are distributing 1/2 times 2/3, and then distribute 1/2 times your complex number, positive 1/3 I. So our first product, 1/2 times 2/3, I'll go ahead and just expand this. 1/2 times 2/3. Then I'm multiplying 1/2 times positive 1/3 I. So we'll be adding the product of 1/2 times positive 1/3 I. My next distribution is with negative 1/2 I. So negative 1/2 I is multiplied by positive 2/3. So I will just include that negative with the fraction. So I'm adding a negative, which is the same as subtracting. And I'm multiplying by positive 2/3. And finally, negative 1/2 I is multiplied by positive 1/3 I. So that's addition of negative 1/2 I multiplied by positive 1/3 I. So let's go back and multiply. Numerators are multiplied by each other, and then denominators are multiplied by each other. So the first fraction is going to be 2 divided by 6. Now don't worry about reducing that at this stage. So don't worry about reducing these fractions right now. Let's just find all of the products first. Next, I have addition of a positive times a positive. So that really will remain addition. Numerators, 1 times 1 makes 1. Denominators, 2 times 3 makes 6. And don't forget, there's an I. And don't forget, there is a complex number involved. So that's really 1/6 I. Our next term, addition of negative times positive. So that really would be subtraction. Numerator, 1 times 2 makes 2. Denominator, 2 times 3 makes 6. And again, we've got a complex number involved, so that's subtraction of 2/6 I. Our last term, we have addition of a negative times a positive. So addition of a negative number will be subtraction. Numerators, 1 times 1 makes 1. Denominator of 2 times 3 makes 6. But do you notice now that both terms involve a complex number? I multiplied by I would make I squared. Now it's important that you remember that I squared is equal to negative 1. So anytime that we create I squared, or if a problem has I squared in it, we need to replace I squared with negative 1. So let's continue evaluating here. I'm going to keep 2/6. Don't worry about reducing yet. I've got positive 1/6 I minus 2/6 I And notice I'm going to replace I squared with -1. So instead of writing I squared, it means that -1/6 is multiplied by -1. Negative times negative means addition of 1/6. And notice we no longer have the complex number because it was replaced with -1. Now scan the terms you have remaining. You'll see that 2/6 and 1/6 are like terms. They're both just constant terms. And then here in the middle, we have complex numbers. So those would be like terms. So we're going to combine our like terms now. 2/6 plus 1/6. So we have a common denominator. It's a good thing we did not reduce 2/6 because it turns out that it already has a common denominator with the other fraction. So 2/6 added to 1/6 would make 3/6. And also notice the complex numbers also have a denominator of 6. So those already have a common denominator. We can go ahead and add +1 with -2 would be -1/6. And don't forget, it includes the complex number. Now the only other thing we might think about doing with this answer is look for any possible reducing because there are fractions involved. And we know that 3/6 is the same thing as 1/2 because 6 is the same as 2 times 3. And that factor of 3 will reduce. So our final answer here, that first fraction becomes 1/2. And then 1/6 is already reduced, so minus 1/6i. In example 8, we have a binomial added to another binomial. So the first thing we would need to do is eliminate the parentheses in order to collect the like terms. To release these terms from the parenthesis, we use distributing. Since there isn't anything written in front of this first binomial, we know that really +1 is there. And if you distribute +1, we're not changing the value of the terms. So we would simply copy 1/4 minus 3/8i. Next, we have a positive or plus sign. That indicates +1. So 1 will be distributed to each term in the quantity so that we can release the parenthesis. Again, 1 times whatever terms are in there is not going to change the value. So it will remain +1/2 and then +5/2i. Now, in order to continue with the problem, we need to identify which terms are the like terms. So 1/4 and 1/2 are both constant terms, so those are like terms. And then -3/8i and +5/2i are like terms. So we'll start with our constant terms. I'm just going to rewrite these in order. 1/4 plus 1/2, and then minus 3/8i plus 5/2i. So these first two terms are like terms, and they do not have a common denominator. Between 4 and 2, we know that 4 is the same as 2 times 2, which we would call 2 squared. Since both denominators have factors of 2, we use the highest power of that factor. So our common denominator would be 2 squared, which is 4. So I know that 1/4 already has the denominator that we need. However, 1/2 does not. So I'm going to start by writing 1/2, and I will have to build up this fraction. How could we make 2 multiply by something to make 4. So 2 times 2 would make 4. So if I'm building up the denominator by a factor of 2, I also need to build up the numerator by a factor of 2. So I have 1/4 plus 1 times 2, which is 2. Denominator, 2 times 2 is 4. Is 2/4 the same as 1/2? So if I divided each of these terms by 2, I would get back to my original term of 1/2. So I know I built it up correctly. But what's nice about this now is I have a common denominator, so in the next step I'll be able to add those. Now let's go back to the complex numbers. I have 3/8 I and 5/2 I. 8 and 2 are not the same, so I need to break down 8 as 4 times 2, but 4 is 2 times 2, so I can see that 2 cubed is the factored form of 8. So both denominators here have factor of 2, but 2 cubed is the highest factor of 2. And we know that 2 cubed is 8. So somehow we need to rewrite these fractions so that both denominators are 8. Well, obviously the first fraction is fine the way it is. So I have subtraction of 3/8 I plus 5/2 I, but this fraction needs to be built up. 2 times what would match 8? So that would be 4. 2 times 4 makes 8. So if the denominator is built up with a factor of 4, the numerator needs to be built up with a factor of 4. So the new values still have negative 3/8 I, but now this numerator would be positive 20. Denominator, 2 times 4 is 8, and it's still a complex number. So we can go back now to get our answer. For our like terms that are just constant terms, both denominators are 4, and 1 plus 2 makes 3. So I have 3/4. For the complex terms, negative 3/8 I plus 20/8 I. Both denominators are 8, so I know I'm going to have 8. Looking at the numerators, negative 3 and positive 20. That would make positive 17. And I need to include the complex portion. Now look back to see if any reducing could be done. 3/4. 3 and 4 don't have any common factor besides 1, so that's done. 17 and 8 also don't have any common factors, so we're complete with our problem here. So I hope you found this video helpful when working with operations with complex numbers.